Hi, I'm Anthony from Navtech Radar. Last Friday, Greg Tomlinson, our Customer Service Manager, ran an introductory Facebook Live video on radar fundamentals, and part of that we looked at the radar equation, and he said that it was a bit like gobble-de-gook to him and he wasn't really sure how it worked. So he asked me to come along and try and explain to you in English what it actually means. So you might be wondering why we're doing this, and here's the radar equation. We've recently launched Navtech Academy, so our mission is to try and increase the level of knowledge on radar and radar technology with everybody by producing articles and sharing information. So this was like one of the first things that we've done. So onto the radar equation. It's got a few key components. We're not going to go into all of them because not all of them are necessarily that important. The main thing is to understand the key concepts. So the first thing is it's all about the power at your receiver. So when you send, radar's got a transmitter and a receiver, so it sends energy out, it reflects off an object, and then comes back. If you haven't seen Greg's fundamentals video, go and have a look because he explains it really well in that. The amount of power we get back determines how easy it is to detect and track an object. There's four key factors that can tell us how well or how much power we're going to get back at the receiver. The first one is pretty simple, it's the amount of power we initially send out. If we send out more power, it's going to be able to go further and come back without losing as much energy. So the first thing that we can do, or the first thing that we should be interested in, is the amount of power we initially send out from the radar. Now on most, especially high frequency radars, we're limited by the type of technology to the amount of power we can actually send out. So for example, on lower frequency units, you can get watts of power. These would kind of be able to cook your lunch at higher frequencies, so we kind of don't want to, we've got to be a bit careful with that. There's certain safe transmission rates, and we want to keep our power down within those, and also within the limitations of the technology. The second part of the equation is GTAR, which sounds a little bit crazy. It's all about the antenna. So the antenna, all that does is focuses your energy in the right direction. And the more we focus the energy, the more power goes in the right direction, and therefore the further along we're able to see. So as an example, so very easy to relate to an example, is a torch. So on the end of your torch, you normally got a focusing lens. And what you can do is you can turn it and you can get a very wide beam. You can't see very far, but you can see a lot to the sides. It's a very, very wide beam. If you then focus it down, you can get a very narrow beam where you can see very far, but you can't see anything off to the side. The radar is exactly the same. If you've got a very tight antenna beam, you can see very, very far, but you can't see off to the sides. If you've got a very wide beam, you can see not very far, but you can see very far out to the sides as your energy is spread out. So that's how the antenna works. The next part is this funny symbol here, which is the radar cross-section. So just like with us, when we're seeing things, certain types of targets are much easier to see than others. So for example, if I was standing 50 metres away, you could probably see me pretty easily. If I was to wear a high-vis jacket, even though I'm physically the same target, you'd be able to see me a lot easier because our eyes pick things up. It's very similar with radar. Objects to radar have sizes that the radar can see that's very different to their physical size. For example, this little corner reflector here is the same size to a radar as a car would be. If you put it next to a car and looked at the radar data, it would give you the same power return, even though it's very, very small, because it's very good at focusing the energy and sending it back. So the key thing to understand on this is that radar sees different targets in slightly different ways to visual, and it's not necessarily the physical size of the target that matters, it's also the shape as well. If we've got an idea of the radar cross-section size of something, the bigger it is, the more power gets reflected back. The last part is on the bottom of the line, which means it reduces the power, and it's range raised to the fourth, so it means it has a really big impact. So what this is about is if you're sending out energy, when it leaves the radar, it goes out and spreads in a cone. It will then hit a target that's at only part of the cone, and the energy is spread out, so only a small part of the energy will then get reflected back from the object, and it'll come back towards the radar in another cone, and the radar will only see again a small part of that cone. So you massively reduce the amount of energy available when you increase the range. Just as a rule of thumb, every time you double the range to the target, you lose 90% of your power. So as you can imagine, if you're trying to get over very, very long ranges and come back again, you lose a massive amount of power and you're getting very, very small signals that you're trying to look for in the background noise. We'll explain a bit more about noise and thresholds and things later, but hopefully that covers some of the fundamentals. So with the radar, it's all about sending out as much power as you can having a nice narrow beam, where you get, so that's what our high definition systems do, a nice narrow beam. Looking for large targets, vehicles or people are reasonably large targets, and they've got a certain operational range. And the further away the target, the harder it is to detect things. Hopefully that's explained the radar range equation for you in English and it makes sense. If you've got any questions, please do leave them and we'll try and get back to you as quickly as possible. If you haven't already, then go and have a look at our full articles on the Navtech Academy on our website www.navtechradar.com/Navtech-Academy. See you soon. Thank you very much.